Hi everyone, Senan this side, and in this video we are going to solve this Geeks for Geeks daily problem, which is linked list matrix. So before we get started, I just want you guys to know that the solution PDF is provided in a GitHub link given below. Be sure to check that out so that you don't have to watch this video again and again. So yeah, let's get started. Okay, so the problem is linked list matrix. Given a matrix of n cross n size, that is a square matrix, your task is to construct a 2D linked list representation of the given matrix. So given this matrix, what you have to do is construct a linked list that looks something like so. If you look at the node structure, it has two pointers. One is towards the right, one is down. So it's more or less like a doubly linked list, but you're not having a two-way direction, but one towards the right and one link in the bottom direction. So how can we do this? So you see, these are the constraints, nothing to be worried about. But what is the idea? The idea is either if you start from this and you generate this linked list, then this linked list, then this linked list, and then you can merge them vertically. That one of the ways. Or what you could do is generate this vertical matrix, vertical linked list, and this linked list, then merge them, then generate this 369 linked list, then merge with this 258. And that is the idea that we are going to use. It's quite straightforward, and the time and space complexity would be n squared because we are going to visit each node twice or once depending on how you see this problem. So let's look at the solution. So I have three functions. This is the main function that we have to write. These two are the helper functions, which are private and should only be used within this class. Okay, so now I'll explain you the way I wrote this code. First is the merge operation. So assume you have two linked lists 1, 2 and 3, and this points to null, and the bottom pointers are pointing to null as well. Similarly, I have 4, 5, 6 as a linked list, and the bottom are singly linked list, and the bottom pointers are basically null. And what I do is I try to make a link from 1 to 4 to 5 and 3 to 6. So what I do is I take a linked list top, which is the linked list singly linked list that is at the top, and a bottom, which is a singly linked list at the bottom. What I do is I declare two pointers, first and second. While first and second, you don't require both of them, but I just wrote it. Now first's down is second, right? This is me assigning the down link of this node. And what I do, I update this first to first's right and second to second's right. And then I reach 2 and 5. So what I do, I assign 2's down to 5. Then I move to 3 and 6. Then I assign 3's down to 6. And when I reach null, I get out of this while. And this is just a void function. So either of the top or bottom, either of them is null. You won't do anything in this solution and you'll just return back. So that's the merge function. Now the second function is just creating this linked list, right? I'm assuming from a broader scale, I know how to create a linked list. So the first I just wrote the merge operation. Now let's create the linked list. So what I do is whenever you are creating linked list, always use a dummy node because the handling of the head or not the head is very simple. Now you take the size n, and what you do is for you also, since this ith row, right, this I represents the row of the matrix that we are trying to make a linked list of. So given this I, so let's say matrix of I, if I is 1, we are talking about this 4, 5 and 6. What I'll do is for all the columns in this first row, 1th row, on the first row, what I do is I create a new temp node, I and j. So this node, then I assign that as the next the dummy, and I update the dummy to this temp. So through this for loop, what I would be having a dummy node and this linked list with me. Now what I do is I delete this. So I have a marker that points to this dummy node. What I do is I say dummy, I reassign this to markers, right? So which is exactly the first element of this linked list, and I delete this marker because I have allocated space right here for this dummy node, so I have to delete that as well. Now what I do is I return this head, which is the dummy, the head of this generated linked list. So that is how I have my this take the row I and the matrix, it would give a linked list representation of that row. This given two rows, it will merge them. The top one would have a would be the top's down pointer would be assigned to the bottom's node. the respect. Now what I do in this is I get the size n, and what I do, I first of all generate the very first row, right? And I call that the current as current, right? So generate linked list from this 0th row of this matrix, and I point the head to this current, right? If I give this 1 to 3 as an input, so this head is pointing to this 1. Now what I do is now I create a next node, and I would generate the next row or the linked list of the next row of this matrix. And what I do, I merge this current row with the next row, and then I update the current to the next. Since I'm updating the current, that is why I have stored the head separately, because I know I would be updating this head and this current. So now this current is this one, this 4, this current is pointing to this 4. Now in the next iteration, what I would do is for I is equal to 2, I would get a linked list, this one 7, 8, 9. And what I would do is basically, this is the current, this is the next, I would merge these linked list, and yep, I'm done. And in the end, I return the head. It's quite easy, it's straightforward. There are just two processes, one to create a linked list from a vector, and the second is merging two linked lists from the through the down pointer. And in the end, you just return the head. So that is what is the question asking. So merging is big of n time, generating linked list is also big of n time, but big of n space as well, right? So if you look, we are calling this for n times, and the merge operation takes big of n time. So and as well as generating linked list also takes big of n time. So this would be big of n times n time, which is big of n square time complexity. And if you see, we are calling this n times and generating n nodes. So this is big of n square space complexity as well. So yep, that is the whole video, and be sure to check the link for the solution in the description below, and I'll see you in the next one.